Today we're going to be doing lesson 1.5, graphing linear functions and inequalities, part 2. Goals, one goal, graphing linear inequalities in two variables. So it's graphing linear inequalities in two variables. So looking at the notes here, graphing linear inequalities in two variables, we're going to graph, the graph of a linear inequality is a half plane. With a boundary that's a straight line. The half plane is shaded. It's your next blank spot. To indicate that all points contained in the region are solutions of the inequality. A boundary is a line or curve that separates a coordinate plane into two half planes. So here's our boundary. So we have our half plane up here and our second half plane down here. So any ordered pair within this shaded yellow section can be a solution. And remember, this shaded yellow section goes forever in that direction. The boundary is a solid line when the inequality contains either a less than or equal to or a greater than or equal to indicate the points on the boundary line are solutions in the solution. So they're solutions on the line as well as the shaded part, creating a closed half plane. The boundary is dashed when the inequality is either less than or greater than to indicate points on the boundary line are not in the solution. Right, so if this line up here were a dotted line, that means ordered pairs that were here, here, or here would not be included because the dotted line means that it's every part in the shaded that's less than the line. First example, we're going to graph 2 minus 4y is greater than or equal to x. So first thing I want to do is get it into y equals mx plus b form. I do that by getting y alone on the left side as it is in the formula here. First step in doing so is to subtract 12 from both sides. When I do that, I'm always going to write the right side of the equal side with the x term first as it appears in y equals mx plus b and the number part second. Remember, the b here is the y-intercept. That's where the graph crosses the y-axis. So when I subtract 12 from both sides, I get negative 4y is greater than x minus 12. Our next step, we're going to divide both sides by negative 4. Remember, when you divide both sides by a negative, you have to flip the inequality. Okay, so I'm going to write this equation as y is not greater than but less than negative 1/4 x plus 3. Remember, you can think of that x up top here as just 1x. That's where this one came from. And when I have a negative below, I can write the negative up top, in the middle, or below. I just can't write that negative twice. So if we think about the rise over run of this slope, it's going to go down 1 and to the right 4. And we always start with the b. So we're going to start at positive 3 on the y-axis, make it up, And then I'm going to go down 1, right 3. Now, if I were to go down 1, right 3, I'm off the graph. So know that you can always do the opposite. Instead of down 1, right 3, or right 4. Sorry, there's one off there. Down 1, right 1, 2, 3, 4. Clearly, I would be off the graph then, right? Down 1, right 1, 2, 3, 4. So instead, I'm going to go up 1, right 1, 2, 3, 4. So just know that sometimes you'll run out of room on the graph and you'll need to do the opposite slope. Instead of going down, you go up. Instead of going left, you go right. So the other key thing to notice here is that it's just a less than. So our line is going to be dotted. So when we graph this line, I'm going to make that line dotted. Remember that you should have arrows on the end of your line. Otherwise, it's a line segment, not a line. So we're going to make some arrows on the end here. Next, I need to think about shading, right? So as we shaded in this upper area, if we think about this graph, because it's shaded above the line, the inequality here would be greater. This inequality, however, is less than, so we're going to shade below the line. So you can think about the y values when you shade, right? Where are the y values smaller? They're smaller below that line. So you can go ahead and shade below the line. You don't have to be perfect with the shading, but make sure that you pay attention to the fact of whether it's less than or greater than, or less than or equal to, or greater than or equal to. So if I ask you for solutions to this, all it said up here is graph, right? But if I ask you for solutions, you could pick any ordered pair in the shaded region. And remember, you can't pick an ordered pair on the dotted line. So you have to pick ordered pairs below that dotted line. Next example, example 2. Again, I'm thinking about getting this into y equals mx plus b format. So when I do that, I have to get the y by itself on the left side of the equal sign. So to do that on this problem, I'm going to subtract 9 from both sides. I get 3y is less than or equal to 8x minus 9. Last step, I need to get rid of the 3. I get rid of whatever's in front of the variable. I do that by dividing each and every part by 3. My answer then is y is less than or equal to 8/3 x, right? I can write the x up here. I can also write the x here. It doesn't matter. It means the exact same thing. And then 9 divided by 3 is 3, so it's minus 3. So when I go to graph this, I go down 3 on the y-axis because our y-intercept is negative 3. So I start down 3, 1, 2, 3, make it up. From there, I have to go up 8, right 3. So I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. So I can only get 2 points on this graph because I run out of room on my coordinate plane, which is fine. Just I would double check your counting to make sure you did it correct. And I'm going to do that now. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. So my ordered pair there is in the correct place. So I'm looking here at my inequality because it's less than or equal to. I'm going to make this a solid line, right? And remember, your line goes up and down forever, so you need to put arrows on the end of that line. Okay, now next I need to think about shading. So I have less than or equal to. So I look at my line here and I'm thinking, where are the y values smaller? Well, this y value is smaller, which means I should shade on the right side of this line, or I think of it as below the line. So I'm going to go and shade that now. Again, we're not asking for any ordered pairs as solutions, but if I were to pick them, I can pick the one on the line because it is equal to. That means it includes the line, and then any other point in the shaded region. Okay, so two more graphs on this page. We've just got simple graphs. So when I look at this graph here, or the equation there, I think about y is greater than 3. So when I think about y is greater than or x is greater than, I think to myself, which axis does it have to cross? Because y is greater than 3, it has to cross the y-axis at 1, 2, 3. That means it's going to be a horizontal line, right? So, and then we also look at the inequality here, right? So we know it's a dotted line. So I'm going to make this a dotted line at 3. I want to make it a little thicker so it's easier to see. Okay, and I'm going to put the arrows on the end. And I look at my inequality here. This inequality is greater than, so I'm going to shade above this line. Done. Next one, example 4. I'm looking at x is less than or equal to 2. That means it has to cross the x-axis at 2. The only way it's always 2 is if that is a vertical line, right? Because I think about, does x equal 2 here? Yes. Y equals 2 as well. But if this ordered pair, it would be 2, comma 2. If I did this ordered pair down here, it would be 2, comma negative 3. So the x value is always 2. That's why x is equal to 2 has to be a vertical line. So we're going to graph that. Just make your line there. It's going to be a solid line because of the equal to right there, right? It's less than or equal to. That makes it a solid line. We're going to put arrows on the end. And then I think about my shading. So this is the one situation where above and below the line does not work. It's either on the left side or the right side. So I think of the left side as less than, and our inequality here is less than, so I have to shade this on the left side of the line. Less than is left. Right, so you can go ahead and shade. And then any ordered pair solution would include the line and anything to the left side of that line. Okay, example number 5. Malik's algebra teacher determines semester grades by finding the sum. So I like to highlight these. Sum of 70% of a student's test grade average and 30% of the homework average. So 70% tests, 30% homework. If Malik wants a semester grade of 90% or better, so if we think of 90% or better, that means it's got to be greater than or equal to 90%. We're going to write and graph the inequality that represents the constraints of Malik's test grade. So test grade is going to be X and the homework grade. Okay. So if I'm writing this, I don't want to use percentages in my equation, right? So X is going to be test, Y is going to be homework. So I need to change those percentages into a decimal. Easiest way to change a percent is just to divide by 100. You could also think about the fact that there's a decimal point and you move it 2 to the left, this strategy always works. So I recommend using that. 70 divided by 100 is 0.7. So I have 0.7x plus 30%, right? So I do 30 divided by 100, and I get 0.3. So we have plus 0.3y. And then Malik wants his test grade to be 90 or better, so it's going to be greater than or equal to 90 divided by 100 is 0.9, so I have greater than or equal to 0.9. Okay, now we have to graph this. So again, I'm thinking about y equals mx plus b form. So I have to rearrange this equation by subtracting 0.7x from both sides of the equal, or the inequality in this case. When I do that, I get 0.3y is greater than or equal to negative 0.7x plus 0.9. And then last step here, I have to divide all three parts by 0.3. When I do that, I get y is greater than or equal to, remember in your calculator, you can do negative 0.7 divided by negative 0.3, math, enter, enter. When you do that, you get negative 2.3x. You could also write that slope, so our slope could be negative 2.3. If I open up the calculator, and I put that in, I would get 7/3. So I could go down 7, right 3. So if it's easier for you to think about it as 7/3, that's great too, or negative 7/3. 0.9 divided by 0.3 is positive 3. And now I'm going to go ahead and graph. So our y-intercept is 3. See our y-axis goes up by decimal points, and 3 is up here at the top. So just make sure you're paying attention to that. And we have the exact same scale on x and y axis. So I can just count down 7 squares and write 3 squares. So that's, I think, the easiest way to do it. So I'm going to count down 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. I'm going to do it again. Down 1, 2, 3, 4, 5, 6, 7. Right, 1, 2, 3. I'm looking at my inequality here. Because I have an equal to, it's going to be a solid line. I'm going to draw that solid line. I like it when you guys do 3 ordered pairs, because you can tell if you're off in counting out your slope. Now, I also want you to think about the fact that, can we go into this negative area here if we're talking about test averages? No, we cannot. So we need to shorten up that line and stop it at the x-axis, right? So there we go. Our average is greater than or equal to, so my shading is going to be above this line in this region. So I'm going to go ahead and shade that. And that's the answer. Okay, so I'm going to answer the B questions right below here of which of these viable solutions for Malik, which are viable solutions for Malik's tests and homework grades. Can he get an 88 on his test? So we have to remind ourselves which is test, right? So the x-axis is our test average, and the y-axis is our homework average. So if he gets 0.88, 88% is 0.88. So we're going to go, you could think of these as ordered pairs, right? So if we look at this, we could think of this as 0.88, comma 1.0. 100 divided by 100 is 1. We could think of this next one as 0.90, comma 0.90, 0.90, comma 0.80 here, 0.95, comma 0.7, down here, 0.95, comma 0.80. Lastly, 1.0, comma 0.7. Okay, so I'm going to look for these ordered pairs on the graph. So if I'm at 0.88, that means I'm close on the x-axis. So 0.88, 0.8 is right here, right? So 0.9 would be in the middle. So I'm somewhere in here, and I want to go up to 1.0. So if I go 0.88 and 1.0, I think I'm going to be right on the line or pretty close to that line. So I'm going to put a check there. So 0.9 and 0.9. So 0.9 would be in the middle, and 0.9 would also be on the line. So if I do 0.9 on test and 0.8 on homework, 0.9 on test, 0.8 on homework, I'm going to be just off that line. If I go 0.95 on test, so I'm really close to the 1, and then I go 0.7 on homework. So right in this middle of this box, I think I'm just off the line as well. If I go 0.95 on test and 0.8 on homework, so 0.95 on test is going to be close to 1, and then 0.7 on homework, or 0.8 on homework, I'm going to be on that line, so I believe that one works. And then if I have 100% and 70% on homework, I'm going to be right on that line again. So that one works as well. So if you want to check these to make sure, because some of them were very close to that line, what you could do is I could plug into my equation up here, right? Plug in the 0.88 for the x and the 1.0 for the y, and then I would know for sure whether or not that solution was on the line or in the shaded region, or below the line, not in the shaded region. All right, that is it. Your homework is also on page 43. So we had two different assignments on page 43 because this is the second day of 1.5. So page 43, 20, 22, 26, 28, 30, 31, and 61. All right, good luck.